Attendees are in listen-only mode.
Good afternoon, everybody, or good morning if you happen to be on the west coast of Canada or the United States. My name is Jason Hodgert, and I'm with PCI Geomatics, and I'm happy to welcome you to our webinar today. This webinar is the latest in a series that we've been doing at PCI Geomatics, showing off a number of the new features of our latest software release, Geomatica 2014, and the things that you can do by integrating imagery and imagery-derived products with GIS applications, specifically ArcGIS. Today, we're going to be looking at disaster response mapping with synthetic aperture radar imagery, commonly known as SAR imagery. And we have a couple of presenters lined up that are going to go through showing you what you can do with SAR imagery, what makes SAR imagery unique, and what you can possibly do. You'll see that SAR has a real propensity to provide detailed information that's not necessarily possible with optical sensors, as well as the ability to collect data at any time, regardless of weather and other circumstances like that. Today we're going to have a presentation that includes a live demonstration from PCI Geomatics and some background and information from a special guest from MDA Geospatial Services on the use of RADARSAT 2 imagery with Geomatica and ArcGIS to rapidly collect, process, and disseminate this information. Before I get to that, I just want to mention a few things about the logistics. Your lines right now, if you're listening to this, are muted. We can't hear you, so feel free to make noise and talk amongst yourselves. If you have a question, feel free to type it into the questions panel at any time. We will be having a dedicated Q&A session following the presentation, but I know sometimes how it can be. You get a question in your mind. If you don't write it down, you forget it. So absolutely write that in there whenever it comes to you. We are recording this session, and we will be sending that out in the next day or so after we let the computer do its compiling and rendering and whatnot. Presenting today, we have our special guest, Mr. Warren Cartwright, Product Manager at MDA Geospatial Services. Mr. Cartwright has more than 15 years of technology product management experience, and he leads MDA Geospatial Services product management activities focused on developing and delivering new value-added products and services based on imagery from RADARSAT 2 and other sensors. Following Warren will be Kevin Jones, the Director of Marketing here at PCI Geomatics. He's based in Gatineau, Canada with myself and has worked in the geospatial industry for over 20 years and has a real background in specifically with radar imagery. So he has put together an excellent demonstration that we hope you all will enjoy, which we will get to shortly. But before that, one of the things that I like to do is to make sure that what we're delivering to you is useful and to learn more about you, so our webinars and our products can go towards the things that you're most interested in. So this first question is basically, why are you here, basically? A little bit about your interest and background. Perhaps you are a remote sensing professional or a GIS professional and you're interested in new processing techniques. Because of the nature of this webinar being about disaster response, maybe you work in that field and are interested in what is this remote sensing? What can I do with remotely sensed data? What is all the fuss? Or of course, there's always room for other. And if you do select other, feel free to let us know what you're doing in the questions panel. We'd love to learn about it and learn more about the people that are interested in the things that we do. Perfect. Thanks, everyone. Just I'll share a little bit of the results there. A full half of you are remote sensing professionals, which is great. That's definitely our target audience for sure. Another large number of you are GIS professionals, and then we do have some of those. Some of you are identifying as the disaster response officials. So I think everybody, no matter where you are or what you are doing, are going to get great value out of the presentation, and I hope you agree. That is it for me for now. I will be back with a couple of other polls later in the presentation, but at this point I would like to pass it off to Kevin Jones to talk about what he's going to be talking about. Go ahead, Kevin.
Thanks very much, Jason, and welcome everyone to our webinar. It's a real pleasure to be able to present to you today. Thanks for making time in your busy schedules to attend our webinar. So just a quick outline here on what we're going to be covering. The real theme of this webinar, along with many others that have been presented in the last few weeks and months, has been that there is more to imagery than using it as a backdrop. Imagery is more than a base map, and I'll just quickly show you some of the other webinars that we've put together that are very application focused and are meant to give you some sense of how easy it is to work with imagery if you have the right software to derive information for operational use. I'll go through just a quick little introduction on working with imagery for disaster response and show some examples of what can be done. And essentially at that point, Warren Cartwright, our special guest from MDA Geospatial Services, will be presenting on RADARSAT 2. And following the presentation from Warren, I'll be taking control once again and giving you a live demonstration on how we can use Geomatica and ArcGIS to work with imagery and derive disaster response information from SAR imagery. So we'll be looking at some multi-temporal radar images of a flood event in Manitoba, and also an image from the Gulf of Mexico oil spill from 2011, and processing that and showing you how we can very easily derive information from that. And last but not least, we'll go through an exciting partnership between PCI, Geomatics, and Esri, and what that presents to you potentially as a customer, what opportunity that presents to you as a customer. We do have a special offer on right now for working with ArcGIS and Geomatica to do a lot of the things that you're going to be seeing today, as well as the things that we've been showing in the recent webinars. So just a quick run through here on some of the most recent webinars that we did. This one, once again, is showing how there is much more to imagery than a pretty picture. These are stereo DEMs that have been calculated from imagery. And so what you're seeing in the middle is actually volumetric information and changes in volumetric information for different stockpiles on this construction site. So we presented this back in September, on September 10th, and we showed how Geomatica could be used to calculate multi-temporal DEMs, and how those DEMs could be compared to derive changes in elevation for this type of application. In addition to, so again, with different application areas, on September 17th, we provided a presentation on the use of rapid eye imagery, which is a constellation of sensors that can provide operational information for agricultural applications, among others. And we essentially showed how Geomatica can be used to derive information. What you're seeing here is some vegetation indices that were calculated in Geomatica. And also we showed how we can publish this content out to the web using ArcGIS Online. So if you missed that, be sure to go and check it out. It is available as a recorded webinar on our website. We also did another webinar that same week on the 18th of September, which was focused on generating 3D building information from imagery. So once again, using the stereo imagery to derive a digital surface model to estimate building heights. We actually ran through, we had a special guest from Esri, from City Engine, so the City Engine software was used to automatically build out a city. And then for iconic buildings, we used a piece of software that PCI makes available known as 3D Feature Extract to model these iconic buildings and texturize the facades with the actual imagery that's available for them. So be sure to check those out if those are topics that are of interest to you. Once again, the focus of these webinars is to really sort of show you how easy it is to derive information from imagery as opposed to just use it as a backdrop. Today's webinar is going to be on disaster response. Here we see a flood map that was derived over the Red River for a flood event that occurred in 2009. This was quite a large flood. I think it was a 100-year flood event. And so this is an example of a product that can be derived, and we'll be going through an operational or a live demonstration on how this map was created, starting right from the raw imagery. So I'll be giving a live demonstration on how to derive this exact map here that you're seeing on the screen, and also to disseminate it out to the web. So all that to basically say that Imagery plus software is a powerful combination for disaster response. We really think that you can get better information quicker out to the people that need to have this information on hand to make better operational decisions. And we'll be showcasing ArcGIS, Geomatica, and we'll be working in this case with MDA with their RADARSAT 2 imagery to derive operational information for disaster response. So hopefully hopefully at the end of this webinar you get a sense of the ease with which information can be derived and the power of these spaceborne sensors to capture this information and disseminate and allow it to be disseminated pretty much in near real time to respond to these critical situations. So with that, I'm going to pass to Warren, who will give us an overview on our RADARSAT 2 and the MDA capability.
Thank you very much, Kevin, and we very much appreciate being asked to join you today and have a chance to speak with all of your customers that have joined us on the webinar this morning. What I'm hoping to show you today is that SAR-based solutions are really an ideal fit for disaster management applications, and how MDA with our RADARSAT 2 satellite has been at the forefront of delivering both SAR imagery and SAR-based solutions to the disaster management community for almost 20 years. For those that maybe aren't as familiar with SAR or synthetic aperture radar, which is what the RADARSAT 2 satellite is, there are kind of four primary benefits, I think, that apply to the disaster management community. The first is in being able to deliver reliable weather-dependent acquisitions. Where SAR differs from your more traditional optical satellites is that it's what's considered an active remote sensing technology, in that the satellite has its own source of illumination, which in this case is a microwave source. And so we're sending that signal down to the Earth. It's bouncing off the surface of the Earth and coming back to the satellite. And from that, we're able to measure and do that regardless of whether there is cloud cover or even darkness. And so, as you can imagine, in a disaster management kind of scenario or in a disaster situation, that ability to get that acquisition regardless of the weather conditions is absolutely critical. The second is there is a unique sensitivity to environmental conditions that has been well documented with SAR. And there are two sides of that we're going to focus on today. The ability to differentiate water from land, and we'll see that in the context of flood mapping. And the second is the ability to discriminate oil on water, and we'll look at that from the perspective of an oil spill as a generally man-made situation. And we have a couple of case studies that we're going to talk to about that. The third one is high-resolution change detection, and again, one of the unique capabilities and that SAR provides is that it allows us to very accurately measure using identical geometry from the acquisitions of the satellite change over time, and in a number of different scenarios that can be used to help in the disaster management situation. Again, it's very consistent and reliable. It's not impacted by atmospheric influences or weather, and for things like landslides, for example, it can be used to very, very high degree measure the impact of a landslide in a particular area. And then finally, we have a capability called INSAR, or interferometric synthetic aperture radar, which, as we see from our kind of first poll, we got a lot of remote sensing pros you're probably familiar with. INSAR is most often used by the mining and oil and gas communities to measure surface deformation. But what we've seen in the disaster management community over the last few years is quite a number of case studies where it's been used to monitor active volcanoes or monitor the effects of earthquakes. And INSAR allows us to look at centimeter to millimeter level of change in the surface of the Earth over very large areas, and so it can be a very effective technique for that. We can go to the next slide there, Kevin. So while SAR itself is an excellent technology and allows us to do some very unique things as it relates to disaster management, really the operational nature of the SAR satellite or the SAR sensor that you're working with is really key, and operational response is probably the most important thing that you can look at during an event. There are kind of a couple of aspects to that, both how quickly you can actually collect the imagery and how quickly that imagery can then be processed and delivered to end users. And this is an area where MDA and RADARSAT 2 really shines, and we really pride ourselves on being the most operationally focused SAR mission available. And I have a little case study in a slide or two that I'm going to show you that really focuses on some of the results we've had in supporting the disaster management community for quite some time. There are three real aspects to RADARSAT 2 that really help it stand apart from the other SAR missions out there: the flexibility of the sensor, and as well MDA's real dedication to customer support. And then the third one is access to a very large commercial partner network that allows us to access imagery and deliver imagery anywhere on the Earth in a near real-time fashion. So Kevin, maybe if we just go to the next slide there. So when we talk about the flexibility of the sensor, what we're really focused on is the ability for us to pick the combination of resolution and coverage that really solves the right problem that our customers have. And in the case of disaster management, we have kind of a wide range of beam modes that are used depending on the situation. RADARSAT 2 actually has 18 different beam modes, and over at the kind of the far right-hand side there, you can see our largest coverage with our ScanSAR wide, which provides 500 kilometer by 500 kilometer swaths at about 100 meter resolution. And down at the other end of the spectrum, we have our Spotlight mode, which offers 1 meter resolution and a scene size of 18 kilometers by 8 kilometers. And then as you can see, we really have quite a range in between, and as a result of that, we can find that right combination of coverage and resolution. There are a few specific modes I just wanted to point out as it relates to disaster management. When really wide area coverage is most critical, and when you're looking at a big oil spill, that can definitely be the case. We get a lot of use out of our ScanSAR modes in looking at oil spill and being able to detect the extent of oil spills. For flooding, many national disaster management agencies will use our standard mode, which provides 25 meter resolution over 100 kilometer swath width. And so that provides you pretty good resolution while still looking at a very large area, and is one of those modes that's just been standardized over time. And then finally our extra fine mode, which covers 125 kilometer swath width, but does it at 5 meter resolution. And so we can look at those very fine details while still covering a big area. To give you some context for that, we have a map of the UK here where we've overlaid a number of different scenes from RADARSAT 2, and as you can see, with something like ScanSAR wide, we can cover a very significant portion of a landmass like the UK in a single scene, down to something like our Quad-Pol data, where we have for all Quad-Pol of the satellite available. And as Kevin's going to show you in his demonstration later, that Quad-Pol data, while not covering a particularly large area, has some unique properties that let us look at oil spills in particular and allow us to really differentiate the type of oil that you're seeing in that marine environment. Maybe we'll just go to the next slide there. And finally, from an operational perspective, as I mentioned, one of the strengths of the RADARSAT ground mission is that we have this incredibly large set of network partners that are located all over the world. And what this means is that we have a ground segment pretty much anywhere where we can downlink data in an emergency situation. So regardless of where the satellite is in its orbits at the time of an event, we're likely going to be able to downlink that data in a very, very effective fashion. And if we just go to the next slide, maybe I'll just show you a little bit of a case study here. So MDA has supported kind of disaster management applications with the European Space Agency and has been involved in doing emergency activation since 2009. So we've been doing this for a very long time. We did some measurement of kind of our response times as part of that program, and got kind of a number of different elements here up on the screen that shows kind of the entire chain. And I'm not going to go into all of them at this point in time. I think the interesting ones to point out are maybe the second one from the bottom, our acquisition time to product delivery. So from the time we acquire the imagery to the time that the product is delivered to the end customer is measured in hours, and in this case it's averaging out at just under 7 hours. But as you can see, these things can get turned around very, very quickly and can be delivered in as little as 13 minutes, which is our kind of minimum in that case. So I think this really shows the ability for MDA to deliver in these disaster management scenarios. So just a couple of case studies I wanted to point out just to give you a sense as to some of the things that we can do with RADARSAT 2. And in this case, we're looking at a couple of examples of oil spills, and then we're going to do one flood, and then I'm going to turn it back over to Kevin to give a live demo of how this stuff can work. So what we have here is an oil spill off the coast of Azerbaijan, captured in 2013. This one happens to be a ScanSAR narrow scene, so it's a piece of a scene that's 50-meter resolution with a 300-kilometer swath width. And over on kind of the right-hand side, you can pretty clearly see the oil on the water. We can also see some of the infrastructure throughout the environment, like the pipeline kind of going across the bottom side, and some of the actual infrastructure, like the very bright returns down in kind of the bottom right-hand corner. If we go to the next slide, what we're really showing you here is the power of increasing the resolution when you're doing monitoring over areas, and where something like our new extra fine beam mode, which ups the resolution to 5 meters but still allows you to look at 125 kilometer by 125 kilometer swath, can really improve what you're seeing in that environment. And in this case, we've got a scene a couple of months later, the same area. I think you can pick out a lot of the same features, but you can see how much more clearly you can see the oil, how much more extensive that oil in that environment is, as well as seeing some of the other features in a lot more detail. So when you're looking at something like an oil spill, you might want to look at potentially increasing the resolution to see a lot more detail. The second case study we have is a flood that took place in Russia in August of 2013. And just to kind of walk through the process that Kevin's going to demonstrate for you, we have a series of scenes that were captured over this area of Russia that got hit by just massive flooding, the worst they'd seen in, I think, 140 years. And if we can maybe just go to the next slide there. We've got just a couple of aerial photos showing, how extensive that flooding was in that region. And then if we kind of go to the next slide, what we typically do, and we've been monitoring this region for quite some time, and so what we have here is a multi-look fine scene, which is an 8-meter resolution product, which was captured in August of 2012, so a year before the flooding took place. So what we do here is we capture kind of a baseline, and then, in this case, exactly a year later, we've got another scene that was captured at what was really kind of the peak of the flooding. And so you can quite clearly see the extent of the flooding and how much water has kind of come into that environment. From that, if we go to the next slide, we can then generate a flood product that very clearly delineates the extent of that flooding, and we can use that with first responders to deliver very rapidly so that they can see the extent of the incursion of the water. If we just go to the next slide, We've got kind of a detailed scene that has been taken out of the larger image, where you can see the real benefit of that higher resolution 8-meter imagery to see where the incursion of the floodwaters has really happened into this particular town in eastern Russia. And so I think with that, I'm going to turn it back over to Kevin, and he can really kind of elaborate on this, and especially with the flood example, take you through how you can actually do that in Geomatica. And here at MDA, we do a lot of this type of work, and we leverage the PCI software on a regular basis to really help our production team do this kind of thing as quickly and meet those very rapid time frames that are needed in that kind of first responder scenario. Kevin?
Excellent. Thank you, Warren, very much. Jason here. Actually, I'm going to sneak in with another poll while Kevin gets the next part of the demonstration together. What we want to know now in this poll actually is what data sources are you using currently now? Obviously, today's webinar is focused primarily on SAR imagery, but obviously satellite optical imagery is a big part of what we do here at PCI Geomatics. Aerial imagery is also big, and that includes UAVs, which is becoming an emerging market in a number of places, depending on regulations and what's going on there. And then obviously field data, which some people are using either in conjunction with remotely sensed imagery or not. Obviously, we would prefer you're using some kind of remotely sensed imagery, and I think as we're going to see, it can make your life a lot easier if you're relying on field data as a primary data source there. So this poll here, many people have had an opportunity to vote. Very even split, but the majority, about 70%, are using satellite optical imagery. A little bit fewer are into aerial imagery, and then actually a little surprising that we've got just over 30% that are selecting satellite SAR imagery. So hopefully we can convince you the benefits of SAR imagery with the demonstration that you're about to see. So I'll be back later with one more poll before the question and answer, but right now I'm going to turn it back to Kevin, and he's going to go through how you can take these products that come from RADARSAT imagery from MDA and what you can do with them in Geomatica and ArcGIS software to make information products. Back to you, Kevin.
All right, thanks, Warren, for that overview, and Jason for handling those polls. So what I've got here is I've loaded up Geomatica 2014, the latest version of our software, and we have different tools available. I'll primarily be working in Focus today, which is our viewing environment, but also we can perform quite a bit of analysis within Focus. So I'll go ahead and open Focus, and I will open up a project that's preset to show you kind of where we're trying to get to. So this is our flood map that was derived from the two images of the Red River flooding from the 2009 event. So very similar to that flooding event that Warren was showing on the Russia-China border. We have a very similar situation where we do have a baseline image, or a dry image, if you will, and then an image that was collected at the peak of the flooding on May 5th. And so what we can do is we can do a change detection on those two images and extract a flood area. Now what you'll notice here on this flood image is you have these very dark areas, and essentially because radar is an active sensor, the SAR energy that's sent from the satellite down to the ground is listening for the echoes that are coming back, and based on the echoes that are coming back, an image is formed. And so what's happening is the water is extremely smooth, and so very little, if almost no energy is coming back to the sensor, and you're left with basically a dark pixel, or an area of very low backscatter. So that's how the flood is represented, and essentially what we want to do is we want to derive an automatic automatic way to delineate the flood extent, which is what we have here. So we perform a change detection, and then we could do some other analysis, and I'll jump into ArcGIS for this part, where we can do some overlay analysis with roads and run some scenarios for doing that. So let me clear this out and start with the raw imagery. So I'm going to load the the two images that I'm going to be working with. So this is the dry image, if you will. I believe it was collected a full year prior to this 2009 image. The beauty of the RADARSAT system, as Warren was mentioning, is that the sensor is being tasked and is collecting imagery all the time over all different parts of the world. So there's a very rich archive of imagery that's available. And so when we're in this situation where we need to do a comparison, we can very easily draw upon the rich archives that are in the RADARSAT archives. So I'll just zoom in here to this area. This is a town that has a dam built around it. Obviously, flooding occurs quite a bit here in the Red River, so there's been a lot of measures put in place over the years to protect these towns. A very, very flat area. There's very little elevation change over this area. So in order to derive the changes correctly, what we need to do is, first and foremost, we need to align our imagery. Now these two images have already been co-registered. In some cases, we can't always get the same resolution or the same viewing geometry over the same location, maybe because when it's a disaster type situation, we tend to go with the first image that's available in order to get an answer quickly to people who need to derive information. So oftentimes when we're comparing that first available image to whatever's in the archives, there can be some shifts if we try to display them one on top of another. So Geomatica can be used to co-register the two images together so that when we're looking at changes, we actually are looking at changes that are physical on the ground and not changes related to errors in co-registration or any other effects. So within Focus, we have our algorithm librarian. This is a very rich tool set that can be used. And within this library, essentially, we have a number of algorithms that are available for performing different types of analyses. So we have radar-specific analyses, spatial analysis, image correction, and so on. And the one that I'm particularly interested in is the change detection intensity. So this is essentially a streamlined way to properly work with SAR imagery specifically. So this algorithm is fine-tuned to work with radar imagery. So as you can see here, we're working with 32-bit real data, and it is calibrated data. So we've removed the lookup table from the data provider, from MDA in this case, and we're working with calibrated backscatter values. And we're able to really pinpoint the changes on the ground. So the first thing that I'm going to specify is my flood image. So this is the image that was collected on May 5th of 2009. And then I'll choose my my reference image as the source. And what I'll do is I'll hit run on this, and it's going to create essentially a new file that has multiple pieces of information in it. It's going to preserve the two channels that are being used for the analysis, so the current flood image and the reference image, and then it's going to also give me the change information as a digital number, and also it's going to give me the change information in terms of the percentile change. So if we look quickly at the information that we're going to be generating, essentially we're working from this dry image, we're comparing it to the flooded image, and what we'll be getting is essentially this is a pseudo color representation of the percentile change on the data set, and then we can actually run a raster calculator function to isolate the changes that we believe to be flooding and derive this map. So I'm just going to go back and see if that's done here. All right, so that's completed. So if I go to my Files tab, I have my, this is the ranked file. So I can actually, I'll run that again. Sorry about that. I need to write that out to a file to do what I need to do next. Actually, I've pre-computed this one, so I won't bother running it again. I'll just clear this out for a second and show you the change. Okay, so here are the 4 channels as I described. So this is the flood image, this is the reference image, the change values, and then the ranked change in terms of percentile. So if I view that in pseudo-color, you can see here that I've got my my change map, and I can identify specific areas within this that meet the change criteria that I'm interested in extracting. So if I pull up these the digital number values, essentially this is the rank of change. So this is the 99th percentile of change. So obviously this is extreme change over here, whereas over here we have very low change. These blue areas are very low change, and then we have some in-between conditions where some things have changed, but really what we're after is this extreme change, the highest percentage change between the 2 data sets. So if I want to isolate that particular part of the changes, what I can do is I can run a raster calculator function. So this is a really powerful part of our software. If you're interested to apply maybe something that you've seen in a scientific paper and you've got a math function that you want to run, it's very easy to basically run the to build the functions out in this raster calculator. So what I'm doing here is I'm basically looking at I want to make sure that the values are valid in my first channel, which is the original image, and then I want to only keep the changes that are above the 93rd percentile change. If that statement is true, I'm going to write a pixel value that is 1, so flooded, and then if it's not true, I'm going to write a pixel value which is 0. So a very simple implementation here. So I'll just run that. It's going to create a bitmap layer, which I'll be able to, which will essentially be the flooded areas mapped very quickly here. Just going to get our ArcMap going for the next part of the demo. So I'll close this out, turn off my change map, I'll zoom out to the full extent, and there you have it. Just in a matter of a few clicks, I've been able to derive the flooded areas. So rather than having to sort of manually interpret where all these flooded areas are, obviously this is the way to go. Very quickly can be done to automate this. Now I've been doing this all within Focus to show you the steps and to properly sort of explain to you how to use the different algorithms. But we have a number of automation tools within our software, and we have a modeling environment, which is here, Modeler. So essentially everything that I was doing within Focus can be replicated in here. So for example, I can import an image, I can pull up CCD in 10, which is the change detection algorithm that I ran. So maybe I would essentially, import my base image, import my reference image, run them through CCD in 10, and then I would basically export that out to a file. And so I can work out the whole workflow here visually. And the beauty of this is once you've built the model, you can essentially just execute it by clicking the play button, and the results will get generated automatically. We also have Python scripting available within Geomatica 2014. So if you are inclined to write some scripts, and maybe you want to combine the Geomatica functionality with some other piece of software, you can certainly do that. So the flooded polygons here, we can convert those out to a shapefile, and we can start to do some GIS analysis, which is what I've got loaded here. So we have our flooded area displayed in polygon forms, and what I've done is I've brought in the road vector layer for Manitoba, for the whole province of Manitoba, and then we've created this hypothetical situation where we have rescue stations, so we have some help available in 3 different locations, and we have this this location here where some people are stranded and they need some help. So we can use the power of ArcGIS to do routing analysis and determine which roads are clear, not affected by flooding, and which rescue station is going to be the quickest one to get to the location. So what we've actually put together is we've published this, so we've done the analysis and we've published a web map for this webinar to show you how that can be done. So what I've got here, I'm just going to load up the web map. It's going to come up here in a second. Just need to log in. So this is done through ArcGIS Online. For those of you who are not familiar with ArcGIS Online, we're able to essentially take the information that we generate from ArcMap and the information that was derived from Geomatica and publish that content out to the web so we can share it easily with decision makers in the field. So this will just take a second here to load. But what you can see, essentially these green lines are the routing analysis that have been performed based on the rescue locations. And this is the town that I was showing earlier where we have maybe some people who are stranded. And so in order to get to these people from the different rescue locations, the route planning can be done through the power of ArcGIS to determine sort of fastest responder to this particular location. So we can show the different routes. This is maybe one scenario, and then we have another scenario where we've got 2 different locations for getting to the site. So the flood polygons should be loading here in a minute. They're just a bit slow to load, but essentially this routing takes into account the flooding. You can see that the routing goes around the flooded part of the image, and it passes through where there is no intersection between the flood and the transportation layer. So this could be quite good for making operational decisions with combination of imagery and GIS. Okay, I'll just quickly make sure I'm still going here. All right, so I'm going to switch now to oil spill, and I'm going to show you how to derive information on oil spills. So just a few quick slides on oil spill detection. Some of the earliest methods that were used were, and are still being used today, they essentially look at the intensity information, so how bright the signal is. And some of the problems with that is the identification of false positives. There is a lot of features, ocean features that are visible on radar imagery, and so identifying which ones are oil versus maybe features that are not of interest is a common challenge. And if we're just looking at intensity of SAR signal, then we're limited in terms of what we can do. So there are some other phenomenon, for example, the wind slicks, which are perhaps if the wind is blowing and there's a large mountain in the way. On the lee side of the mountain, we get lower wind speeds, and therefore it looks like it's a slick, but really it's just lower waves. We get rain cells, so depressions, pressure systems that are pressing down on the ocean that calm the ocean down that could appear to be a slick but are not. And then we do get natural oil seeps, which are a little similar in terms of the intensity, but if we, as you'll see in a minute, if we use polarized information, we can really differentiate them. It's also difficult to separate thick oil from thin oil, and so here's an example of a wind slick. You can see here there's a large mountainous feature on this island, a volcanic feature, and behind, because the wind is most likely blowing from the south towards the north, we get this effect on the ocean, which appears to be a slick, but really it's just related to the position of the mountain with respect to the ocean. So Quad-Pol data, or fully polarimetric information, can be used to reduce false positives and better distinguish the oil slicks. So rather than just looking at the intensity of the SAR signal, we can look at the multiple polarizations that are coming back or sending and receiving information and say something much more detailed in terms of the oil slicks that we're seeing on the imagery. So there's several algorithms that can be run. The one that I'm going to be showing is commonly known as the conformity coefficient, and this is an algorithm that we have available in our software. There's quite a few polarimetric focused algorithms in our software. This is based on a paper by some researchers at the Fisheries and Oceans Department in Canada that were looking at the use of RADARSAT 2 polarimetric data for identifying thickness of oil. So that science has actually been implemented in our software and produces very good results. And we can also look at the thickness of the oil. So in terms of the process for deriving this information, we essentially need fully polarimetric RADARSAT 2 data. We can look at computing different polarimetric discriminators. The one that I'm going to be focused on is the conformity coefficient. And then based on that, we can derive information. So what you can see here, just quickly before I give the demo, is three sort of oil features that on the intensity. In terms of the intensity, the detected information that's coming back to the sensor, and when we actually run a polarimetric discriminator, we can see that there is actually a difference in terms of the response of those different features, and the reason for that is essentially the thickness of the oil. So the thicker the oil, the more attenuation of the waves will occur, therefore the smoother the feature will be. And so we don't just look at how smooth it is, but we can derive these polarimetric signatures to really say something about how much quantitative response there is in terms of the SAR energy that's coming back. So let me just quickly run through this oil slick scenario here. So I'm just going to clear out this flooding example, and I will load up the image. This is an image of the Gulf of Mexico oil spill from 2011, and what I'm loading now is a calibrated version of the image. So this is in sigma naught, and so we're looking at backscatter values here. The first view that we get is a multicolor view. You can see that we have 4 channels of data. We have HH, HV, VH, and VV. So let me just load HH. And so here you can see some of these features, some of these oil features. But as per the PowerPoint slide, we really can't tell much about, you know, inside this black feature, what's happening? Is it thick? Is it thin? Is it oil? Is it not oil? So in order to derive more information on that, we can run the conformity coefficient algorithm. So I'm going to load that up here. So once again, we can find our algorithm. I'm going to open it up, and I'm going to select all my channels, and I'm going to run that, and it's going to display the results in the viewer for now. And I'm just looking at my notes. I think this takes, oh no, this one's pretty quick. Okay. There it is. So there's the conformity coefficient version. So now what I have is I have a file that I can work with that has essentially had this scientific paper applied to it. So I can essentially now derive information from this layer, which is much more informative than just purely the intensity information. So what I'm looking at now is the conformity coefficient values for each pixel. So if I'm over the flooded area, I'm getting a certain value, and then if I'm over the ocean, I'm getting a different value. And the way that I'm going to essentially try to get to a product here is I'm just going to preload some intermediate products that I generated to get to the final product. So the steps are essentially I scaled the data from 32-bit to 8-bit. I applied a median filter, so I'll load those three right now so you can see what was done earlier. So this is just the same version of what you saw, except it's an 8-bit version, which makes it a little bit faster to process. And then once we've done that, we can actually filter the data quite a bit to remove or smooth out the layers to make it easier to automatically extract these features. And then once we've done that, we can run again, we can use our raster calculator to remove anything that is not oil. So in this case, we can simply pull up our 8-bit filtered imagery. We can go under raster calculator, and then we can paste in this value, and essentially what we'll get is a result that doesn't have any of the open ocean and only retains the slicks. This one, yep. So once we have that layer, we can now run a couple of different things. We have a nice tool within Geomatica to automatically extract polygons. So we can look at the digital, the information in the channel, as well as try to pick out different shapes and automatically extract out the information from the imagery. So I'll just quickly load that up here. Yep. So here's my image, which doesn't have any more open ocean in it. It's only the grayscale, or only the flood oil spill areas. So you can see now that if even by applying a pseudo lookup table on these oil slicks, I can get really good information and good detail in terms of the oil spill itself and how thick or how thin the oil is. So the conformity coefficient, so we've got some high values and some lower values that are representing how thick or how thin the oil is within this particular oil spill. So much nicer result to work with. And sort of the final step to get to our product is we can run once again another algorithm, and this one is known as our extract polygon algorithm. So it's called XPolRAS, and I can select my layer and select my values. So I'm going to use 1, so at the pixel values have to be at least 1, not zeros. and I can set my threshold at 210. So in this case, I'm trying to keep the essentially the values that are representing oil, these oil slicks, and then I can search this is a number of pixels, so I'll just run 2500, and I'll run that to show that in the viewer. And very quickly what we get is polygons. So rather than having only the raster version, we now have the extent of those these oil spills automatically extracted. So we can combine this information together with the raster data and the calculated information to then disseminate this out, very similar to what was done with ArcMap, and push this out to end users who need this information. So Jason, with that, I'm going to pass it back to you.
Excellent. Thank you, Kevin, so much. And at this point, I have one more poll to go to before we get to a little bit of wrap-up and then the Q&A. So the the last poll is, having seen from us what we think makes SAR imagery an excellent option for disaster management. What kinds of barriers do you think that might still be in your way before using this? Perhaps you might need higher resolution imagery than what you've seen here, and that's too cost prohibitive, or the vast frequency at which you plan on purchasing imagery, if this was your chosen place, might be too costly. Again, now this is obviously not just any layperson can interpret the data you see here. So hiring and training qualified analysts could be something that could be preventing you from getting into this. Or like a number of you, I know some people on the line identified as pure GIS specialists, and perhaps you're more accustomed to getting your information-derived products delivered to you pre-processed, and maybe some of you would prefer to have a service do that. No wrong answers here. We're liking to always want to see what people think of the webinars, what they think about what we have to offer from a product and service standpoint, and what kinds of things see it from your point of view. Many people have had a chance to vote. Pretty even split right across the board there. A lot of people are looking for higher resolution imagery or high frequency, and basically all the answers pretty much across the board were pretty even. Now, before we get to the question and answer, Kevin does have a few things to talk about, ways that you can get software and imagery at a great deal, possibly. So, Kevin, I'll pass it back to you one last time, and then we'll get to Q&A shortly.
Great, thanks again. This will be quick. So I just want to quickly mention that we do have a great relationship between PCI, Geomatics, and Esri, and that's the reason that we're giving this webinar today, is to highlight some of the capabilities that can be brought to bear between both our software packages. Esri actually turned to PCI when they needed to process 300,000 images for their ArcGIS Online imagery base map. And so our technology was used for that. And if you go to ArcGIS Online and flip on the imagery layer, chances are you'll see a lot of data that was processed by Esri using our GXL system on the Amazon cloud. So we've done some really cool projects together, not only in terms of helping them solve these big data challenges, but we've also done this really neat program where we essentially partnered together with Esri and also with MDA and Blackbridge, or for the Rapid Eye data, to provide imagery and software together with training. So we had about 22 recipients of this grant program who received software and imagery and training, and they're able to conduct some projects where really they're trying to get to a point where they're leveraging the software and they're leveraging the imagery to get more from it and to get more than just displaying the imagery as a backdrop and to get information from the imagery. Here's an example of the Metropolitan State University of Denver, which was one of the recipients. They were able to use ArcGIS and Geomatica together with RapidEye and RADARSAT 2 data to study glaciers. And another quick look at a case study is the Madison County Council of Governments in Indiana. They were interested to study the long-term changes to the surface temperature related to changes in urban sprawl, essentially, around, I believe it's Indianapolis. And so they were able to leverage RapidEye imagery and Landsat imagery, as well as our software to derive this information. So we want to encourage you to find out more if you are eligible to do something very similar. What we've been showing here in this webinar as well as previous webinars is how ArcGIS and Geomatica can be used together with RADARSAT 2 imagery or RapidEye imagery to derive information, and really how easy it is to do so. We do have some data sets available. MDA makes some sample data sets available on their website. We've put the link here, and I believe Jason will be sending you the link via the chat window as well, so you can click on it from there. And there is a special offer on right now where you can buy ArcGIS and Geomatica as a bundle and also have access to imagery at a discounted rate. So if you're interested in that and you want to find out if you're eligible, by all means, get in touch with us, marketing@pcigeomatics.com, and we'll direct you in the right place for that. With that, I think, Jason, we should probably go to the Q&A. It's been a lot of information here, and I'm sure there's some good questions.
There absolutely are a number of good questions. I just did want to mention that link that you saw on the screen previously. I did send that out during the chat, so it's clickable and you can get there more quickly. Also, before we get to the Q&A, I always want to mention that if you are not a Geomatica user, the link that I just sent seconds ago, you can get a free 15-day trial of Geomatica at getgeomatica.com. And you can start working with some of the sample imagery and Geomatica software right away to start doing some of the things that we have done. Okay, I'm just going to sort of go through the questions here as I see them. Was this this question came in from the when you were doing the flood demonstration there, Kevin? Was the data that we used there, was it delivered as calibrated backscatter values, or did you have to derive that using the PCI software?
Yeah, so the Geomatica software essentially can work with intensity data, or it can remove the lookup table that is used. Basically, the data providers, MDA included, and others, what they do is they make sure that they're providing a high-quality product. So when they process an image, they apply a lookup table, whether it's a mixed land type or an ocean land type, to highlight the features. And so when the imagery that you get from them, in order to get back to the backscatter values, can essentially be removed. So the lookup table can be removed to get back to the raw backscatter values. So we did that in Geomatica. It's very easy to do. When you load the data in into the software, you can essentially just specify whether you want to look at non-calibrated or calibrated data. It's actually very easy to load data directly into Geomatica in the right format.
Excellent. And another one here, a user is wondering if there are any functions or tools inside ArcGIS that can do a lot of what you were doing in Geomatica, specifically the change detection. Is there that kind of functionality built into ArcGIS?
Yeah, it's a good point. There is functionality for performing change detection within ArcGIS, absolutely. I guess the limitation there would be the support for radar imagery and really this kind of detailed analysis that we're doing in terms of working with calibrated data. That's probably where you're going to run into some issues. So the power and the support of radar imagery within the Geomatica suite of software is at a different level than where it is with ArcGIS. But yes, there are tools within ArcGIS. I guess it all depends to what level of accuracy you need to get to in terms of the products that you're generating.
Fantastic. I have one here that is, you sort of went over it earlier, I believe, but the two images that you were going over with the in the Red River flood example, were they collected using the same scan mode, the same polarization, and well, what scan mode was used in that? Or I guess a follow-up question would be, what do you do if you have a situation where you have two images collected over the same area, and they were collected in the different scan mode?
Right. So I don't remember exactly which beam modes were used for the Red River. I think one was a standard. They were both standard beam, but maybe from a slightly different viewing geometry or a beam position, if you will. So in the case of the Red River, it's not a big deal because it's so flat there that they're, even if you're using a different viewing angle, the artifacts that are present in radar imagery are not as severe. So I'm thinking of things like topographic effects, shadow, foreshortening, and layover, those kinds of things. So not as big a deal, which was easier to handle.
Perfect, thank you. And another one here just came in. I know that we do support other SAR sensors, not just the MDA sensors, but specifically we have a user here that is interested in UAV SAR, and I'm not quite sure where we are on that actually, Kevin, but I'm sure you do know.
Yes, we do support UAV SAR data. And I'm just trying to find my image. There it is. So I have that image that I was showing you in the PowerPoint is what I'm going to load up here. So I'm just going to turn this off and zoom to the overview. Oops. So we do support UAV SAR data. There it is. So this is a UAV SAR image. You can see that it's all loaded properly. We've got different channels of, I'm not 100% familiar with UAV SAR data. I'm not quite sure why I think there's 3 separate channels here. But essentially the data does load, and the analysis that I performed is also possible within the software.
Well, that's great. I think from what I see, it seems to be most of the questions. If you have a question out there and we did not get to it, I apologize, but we will be sending out a detailed Q&A with the recording in the next day or so. So with that, I want to thank Warren Cartwright from MDA for joining us and putting together the detailed presentation on why and what you can do with SAR imagery. Thank Kevin Jones for putting together the live demonstration and showing how we can use Geomatica and ArcGIS to build products to get great use of this information. And thank you all for joining us. And by all means, go to our website, getgeomatica.com, check out our webinars page, and we'd love to have you join us again for a webinar in the future to learn more about what you can do to make imagery more than just a base map in your workflow. Thanks, everybody, and have a nice day.